oldest forms of construction used by man. The beauty of today's masonry is assured for years to come, as demonstrated by the endurance of many monumental structures of the past. Long Beach, California earthquake, 1933. Reinforced masonry came to the forefront following this and other earthquake disasters and demonstrated that unreinforced masonry required additional lateral strength, ductility, and damping properties to resist major earthquakes. Today, grouted reinforced masonry is used to resist seismic, wind, earth pressures, and heavy loads. This masonry system consists of steel reinforcement and masonry units bonded together by pouring grout into a wall. The structural benefits of grouted reinforced masonry allow thinner walls to be constructed, longer spans, and taller and stronger walls. In addition, grout in a masonry wall provides excellent resistance to sound transmission. Grout also increases the wall's fire resistance rating. A solid grouted wall, 6 to 8 inches thick, has a 4-hour fire rating. Grout is not mortar, and it is not concrete, but is a cementitious material unique to reinforced masonry. Grout can be delivered by ready-mix trucks or mixed at the job site. Sand, Portland cement, water, and pea gravel are the basic ingredients of grout. There are 2 types of grout used in masonry construction, and they are specified by proportions of the materials used. Fine grout is made of 1 part Portland cement, 2 1/4 to 3 parts sand, and water. Coarse grout adds 1 to 2 parts pea gravel to this mixture. Water content is adjusted to provide fluidity and to enable placement under various job conditions. The fluidity allows the grout to seek into crevices and around steel reinforcement and protrusions. Fine grout is used in walls or areas where the grout space is small, narrow, or too congested because of the reinforcing steel. Coarse grout is used where the width of the grout space is larger or less congested. Building codes give grouting limitations based upon the actual masonry materials and construction methods used. Based on laboratory or field experience, other approved proportions of ingredients or admixtures may be selected to achieve a desired strength or physical property. Admixtures containing chlorides should never be used. Chloride salts will cause corrosion of the steel embedded in the grout. Fluidity is measured by a slump cone test. Both types of grout must contain enough water to provide a slump of 8 to 10 inches. Here at the Masonry Demonstration Center, several types of walls were constructed to show proper grouting procedure. In laying up masonry units, care should be taken to prevent mortar from excessively protruding into the grout space. This can be done by parging the extruded mortar to the hollow units or by beveling the mortar as the bricks are placed. Other approved methods may be used to keep the grout space free of mortar droppings. Ties are required in multi-width walls that are grouted higher than 12 inches at a time. When the mortar joints gain strength, these ties secure the withes together and resist the lateral pressure of the grout, preventing bulging or blowing out of the withes. Tie size and spacing shall be in accordance with the requirements of the applicable code. Ties may be joint reinforcing or wire in the form of a rectangle or Z, and may also be used as positioners to properly place reinforcement. Horizontal reinforcing steel is laid in the wall as the wall is being built. Vertical steel may be put in as the wall is constructed, or it can be placed after the wall is built. The steel is dropped through positioners to assure proper alignment. When grouting the cavity of a multi-withe wall, vertical barriers or dams are used. This graphic shows without barriers, long flow lines and segregation of materials can occur. To prevent this, barriers are used to limit the distance that the grout flows horizontally and can be spaced up to 30 feet apart. This controls the amount of grout used at any one time. Masonry walls may be grouted solid after the vertical and horizontal reinforcing steel is in place. All cells in grout spaces are completely filled with grout. Hollow unit masonry walls may be partially grouted with grout confined only to those cells which have horizontal and vertical reinforcing steel. The grout is confined to a horizontal cell with expanded mesh, shown here in yellow. Expanded mesh or other screen material is used to confine the grout to only those areas or cells with steel reinforcement. Cross webs are mortared to prevent grout from flowing between joints and into empty cells. This graphic shows the placement of steel, mesh, and grout in a low-lift construction sequence. The mesh and steel are in place, and the cells and bond beams are then grouted. With our demonstration wall, we can see the flow of grout through the bond beam with the horizontal steel in place and the vertical steel placed 40 inches apart. Partial grouting reduces dead load and requires less grout. Building the wall to its full height and then grouting is an economical method in constructing reinforced masonry walls. It allows the mason to continually lay masonry units without waiting for the walls to be grouted. This is called high-lift grouting and is used when walls and grout pours exceed 5 feet. The total height of masonry to be grouted prior to the erection of additional masonry is called a grout pour. Grout is lifted in increments called lifts. A grout pour may consist of several lifts, though lifts may not exceed 5 or 6 feet in height. Cleanouts are used to remove mortar droppings and other debris from the grout space and can be provided by leaving out a unit or cutting holes in the face shells of hollow units. Cleanouts must be at every vertical bar, but spaced not more than 32 inches apart. At the bottom of the wall, the cleanout may be covered with a layer of loose sand to prevent mortar droppings from sticking to the foundation. When the wall is complete, all excessive mortar protrusions are knocked off. The debris is removed from the grout space by blowing it out, washing it out, or cleaning it out by hand. The cleanouts are sealed with either a masonry unit, a face shell, or a form board braced to resist the pressure of the poured grout. Cleanouts may be omitted if approved provisions are made to keep the grout space clean prior to grouting and are not necessary if walls are built and grouted to 5 feet high or less. This method of construction is known as low-lift grouting. When the reinforcing steel is in place and mortar does not protrude excessively into the grout space, the wall is ready for grouting. Selection of the method of grouting is usually made by the mason contractor and is based on site location and the amount of grout to be placed. For small amounts of grout, pails are often used, especially when horizontal bond beams are being filled in partially grouted walls. Large buckets, hoppers, or grout pumps deliver large volumes of grout directly to the top of the wall. As seen here in our demonstration wall, the grout completely surrounds the reinforcement and masonry units and bonds them together, producing a stronger, unified structural system. Grout must be consolidated just like concrete. Consolidation eliminates voids and causes it to flow around reinforcement, mortar protrusions, and projections of the units. Lifts greater than 12 inches must be consolidated by mechanical vibrators. As there is only a small volume to be consolidated in the cell or grout space, the mechanical vibrator need only be used for a few seconds in any location. After water is absorbed into the masonry unit, and before the plasticity of the grout is lost, the grout should be reconsolidated. Proper consolidation will assure that the grout bonds to the masonry units, forming a homogeneous system. The next lift of grout may now be placed immediately on top of the previous lift, consolidated and reconsolidated. If there is a significant delay between grout lifts, the grout is stopped below the top of the unit to create a shear key. Under normal conditions, no special curing of grouted masonry walls is necessary. Much of the water in the grout is absorbed by the masonry unit. The water is present to aid in the curing of the Portland cement. Publications and municipal building codes outline the procedures for construction under adverse weather conditions. In order to determine the compressive strength of grout, specimens are made that will represent the hardened grout in the wall. The specimen is made in a mold consisting of masonry units proposed for construction. The units form a space approximately twice as high as it is wide. The space is lined with a permeable paper or porous separator to prevent bonding the grout to the masonry units, but still allowing the excess water to be absorbed. A representative sample of the grout is placed into molds in 2 layers, puddled, and kept damp and undisturbed until taken to the laboratory, where it is placed into a fog room until tested. Both fine and coarse grout must have a minimum compressive strength of 2,000 pounds per square inch. This compressive strength ensures bonding of the grout to the reinforcing steel. This specimen was tested well beyond its minimum load. When high-strength masonry is specified, the use of high-strength grout is advised. Because of the strength of clay masonry units exceeds the specified strength of the masonry assembly, masonry prisms are made to establish the required grout strength. By following these recommendations, building with grouted reinforced masonry will result in strong, economical, and reliable structures.